Right, good morning, viewers, all students at Maths ACLU. Welcome to my YouTube channel. Today we are talking about nature of roots. Nature of roots. When you talk of roots, we are talking about the values of x is when you are solving a quadratic equation. So the nature of roots, we want to check what kind of roots do we have. That is the nature, the kind of roots that we have. So our nature of roots are going to be determined by what we call a discriminant. The discriminant. This one is given a symbol, this symbol. That is the discriminant. So when we talk of a discriminant, we are talking of what is inside the square root. So discriminant is equal to b squared minus 4ac. You remember on the when you say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This is our quadratic formula. So when you talk of a discriminant, we're only talking about this one, the one inside the square root sign. So this is the discriminant. This one alone is going to give us the nature of the roots, what type of roots we have. Right, so let me give you the conditions that will give you the description of your roots. Right, if you calculate your discriminant, then you find that the discriminant is less than 0. Then we say describe the roots. This means your roots are non-real, or you can say the roots are imaginary, with imaginary roots, or you can say roots are complex roots. They are an element of complex numbers. You know what we mean when you talk of complex numbers. That is after you calculate your discriminant, you find that the number that you get is negative, that is less than 0. So that means the description of your roots are non-real, or you can say roots are imaginary, or you can say roots are complex. Right. Now, again, when you also calculate the discriminant, and you see that the roots are greater or equal to 0. When roots are greater or equal to 0, that means roots belong to a set of real numbers. Roots are real. They are real numbers. These ones are not real numbers. The complex roots are not part of real numbers. So if you get your discriminant equal to 0 or any number greater than 0, then roots are real numbers. Right. Now the third thing, let's number them properly. Let's say 1, then we say 2. Then the third description, you calculate your discriminant and you get that this third one is we break this greater or equal to 0. Let's say roots are equal to 0. So the discriminant is equal to 0. If the discriminant is equal to 0, then it means your roots are equal. Roots are equal. And when you talk of equal roots, I mean, let me have x minus 2 equal to 0. Right? When we say solve this equation, you find that x is equal to 2 on this bracket, or x equal to 2 on this bracket. So we are saying roots are are equal. Roots are equal here. Or in some cases, we will say it's one root. And that is the most appropriate one. It's one root. Because two is just a 2. So if the discriminant is equal to 0, it means it's one root. It's one root, or roots are equal, whatever you want to say. So we can say roots are equal or one root. Right. Now let's talk about we are breaking number 2 here. We are breaking it. So we have said delta is equal to 0. Now we say delta is greater than 0. Right. When delta is greater, we've talked about, or here we said greater. When delta is greater than 0, we are now saying our roots, yes, these are real roots from this description, but the roots are different, are two different roots, or two distinct roots, or you can say two distinct roots. Two distinct roots. Two distinct roots or two unequal roots, whatever. Unequal. Two distinct roots, two unequal roots, two different roots. That is when delta is greater than 0. Giving an example, you can have x minus 3, x minus 2 equal to 0. You see this one? We will say x equal to 3 or x equal to 2. So these are the two different roots. This is x1, x2. There are two different roots. This is what we are talking about. Right now, let's also have another part. Another part which says delta, you calculate delta. You calculate delta, then you find that delta is a perfect square. Is a perfect square. What does it mean? If delta is a perfect square, it means it implies the roots are rational. Roots are rational. A rational number, a number that can be expressed as an exact fraction. Roots are rational. Right. Then, number 6, you calculate your delta and you find that delta is not a perfect square. It is not a perfect square. And we know what we mean by perfect square. What does it mean? It implies roots are irrational. Roots are irrational. An irrational number, a number which cannot be expressed as an exact fraction. For example, e.g., you can have x equal to root 2 is an irrational number. You can also have x equal to root 7 is an irrational number. So you have to know these 6 conditions. 1, delta less than 0, it means the roots are non-real, imaginary, or complex. You don't write all these things. You just choose one description. If you want to say roots are non-real, you are done. Or if you want to say roots are imaginary, fine. Or roots are complex. Then delta greater than 0, it means greater or equal to 0, it means roots are part of the real numbers. Right now, from those, especially from the second one, we break it. Delta equal to 0. It means roots are equal or one root. There is only one root. Then delta greater than 0. Roots are two different or two distinct roots or two unequal roots, whatever way you want to express it, then delta from all of the above, we can now have another new condition. If delta is a perfect square, then the roots are rational. If delta, I'm saying delta, this is the discriminant, yes. The discriminant is not a perfect root, a perfect square, sorry. This implies roots are irrational. Irrational. Right, now, let us have one example from whatever we've been discussing. Let me use this part. Let's have two examples, in fact. Two examples. Right now, given x squared plus 5x plus 6 equal to 0. Without solving the equation, describe the nature of the roots. Without solving the equation, describe the nature of roots. So now when you say without solving, it means we are just only going to use the discriminant. So let's have our discriminant. Our discriminant, which is equal to b squared minus 4ac, is going to be equal to, your b is 5. So it's 5 squared minus 4. Your a here is 1. So c is 6. Right. Now we go. Equal to 25 minus 4 times 1 times 6. That's going to be 24. Equal to 1. So your discriminant is 1. So what does it mean now? If the discriminant is 1, we said is greater or is greater than 0. It's a real number, yes. But then there's also another condition. Delta is a perfect square. Roots are rational. So describe the nature of roots. You can say, therefore, roots are real and rational. Roots are real and rational. They are real because of it's greater than 0. It's a perfect square, so they are rational. So that is how we describe the nature of the roots. And now the second part, the second example. Second example. X squared plus 4x plus 4. X squared plus 4x plus 4 equal to 0. Describe the nature of roots without solving the equation. Right, now our discriminant is equal to b squared minus 4a squared. B is 4. So it's 4 squared minus 4. Our a is 1. Our c is 4. So that is going to be equal to 16 here minus 4 times 4, 16, which is equal to 0. Then what does it mean now? 0. Our discriminant is 0. It's part of the real numbers. Roots, therefore, roots are real. There's also another description. Roots are real and equal. We said if the discriminant is equal to 0, roots are equal. So roots are real and equal. Right. So for now, these are the only two examples that I wanted to give but we will continue.